Hey everyone, welcome back to the channel with today's LeetCode DCC question. Remove zero sum consecutive nodes from the linked list. In the previous interviews of Amazon, they have asked this question. Let's read the problem statement. Given the head of a linked list, we repeatedly delete consecutive sequences of nodes that sums to zero until there are no such sequences. After doing so, return the head of the final linked list. You may return any such answer. Let's take a small example and understand the question. Let's suppose we have a given linked list like 1, 2, 3, -3, and -2. So given a linked list, we have to find if there is any such sequence which sums is equal to 0. If we see these two nodes, this sums is equal to 0. That means we have to remove these nodes. Once we remove these nodes, the linked list form will be this. Now again we will see if there are any such sequence whose sums is equal to 0. Again we can see these two nodes sums is equal to 0. Again we will remove these two nodes. Now we are left with only one. Now there is no such sequence. That means this is the final answer. So basically what we have to do, given a linked list, we have to keep finding the sequences whose sums is equal to 0 and we have to delete those nodes until we are not left with any such sequence in the linked list whose sums is equal to 0. Now let's see how we can solve this question. Suppose we have a value 6 and we perform multiple operations on it, like adding some value, subtracting some value, again adding some value, again subtracting some value. We did some operations and the final result is 6. So starting from 6, reaching to 6, can we say whatever operations we did, the sum they added to this value is equal to 0? For example, if we have 6 and we do some operations like we added 2, subtracted 2, added 4, added 3, again subtracted 7. Now we will see if the final value, what is the final value? 6 plus 2, 8, 8 minus 2, 6, 6 plus 4, 10, 10 plus 3, 13, minus 7. Again it is 6. So can we say that these operations added 0 value in the 6? So if that is the case, can we use this approach in finding the sequences? So if starting from 6, reaching to 6, can we say this sequence, this sequence of operations, we can delete because this value is equal to 0? Let's see how we can use this approach in the question. Now let's take one example. Suppose our linked list is 1, 2, -3, 2, 1, 5, and -1. Suppose this is the linked list they have given. Now we will perform a prefix sum of these elements. Now for first node, the value will be 1. Now 1 plus 2 is 3. 3 minus 3 is 0. 0 plus 2 is 2. 2 plus 1 is 3. At this point, if you see, we have reached to 3. And if we look back, we can see that earlier also we got some same value 3. That means starting from 3, we are reaching at 3. That means whatever operations we performed from here to here, it added 0 value in it. If it added 0 value, that means the summation of this node's value is equal to 0. So if we see -3 plus 2 plus 1 is equal to 0. So we can remove these nodes. After removing these nodes, we are left with 1, 2, 4, 5, -1. So prefix sum, now again we will do prefix sum. 1, 3, 7, 7, and this was -5. Let's suppose it is -5. 7 minus 5, 2, and again it is 1. So again we will look back and see we have got this value earlier also. That means whatever operations we did from this point to this point, it added 0 value. If we see 2 plus 4 minus 5 minus 1 is equal to 0. So we can remove these nodes. So we are left with only 1. Now let's see how optimally we can find and look back whether this value prefix sum we have got earlier or not. For that, what we will do, we will create a data structure hash map. We will use this hash map to store the prefix sums. For example, if we take the same example again, 1, 2, minus 3, 2, 1, 4, minus 5, and minus 1. So what we will do, we will create a hash map. So every time, whatever prefix sums at this node, we will see whether we have already got this prefix sum earlier or not. So every time we will see. So initially, we are starting with a 0 value. That means we have at least 0. If we don't add anything, that means we have a 0 value in the list. So initially, we will initialize with 0 with value 1. That means at least we have 0. Now, starting from 1, we have prefix sum 1. We will see whether we have 1 in the hash map or not. So we don't have 1, right? So this indicates prefix sum. We don't have 1. So we will push 1 and increment the counter with 1. Now 1 plus 2 is 3. So again, we will see in the hash maps, 3 is also not there. So we will add 3 in the hash map. 3 minus 3 is 0. We will see whether we have 0 in the hash map or not. Yes, 0 is there. That means all these sums will constitute to 0. If we see 1 plus 2 minus 3 is equal to 0, that means we can remove it. So while removing, we will reduce this, remove this from the hash map, because as we will remove this nodes, that means now we will not get the sum 3, we will not get the sum 1. So one by one, we will iterate back and remove. So minus 3, we haven't pushed 0 right now, right? So we will remove 3 from the hash map, 1 from the hash map. Now we will delete these nodes. So we will left with 2, 1, 4, minus 5, and minus 1. Now we will have the prefix sum 2. So 2 is not present in the hash map. So we will increment the counter of 2. 2 plus 1 is 3. 3 is also not in the hash map. So we will add 3. 3 plus 4, 7. 7 is also not in the hash map. We add 7. 7 minus 5 is 2. We will see 2 is in the hash map. Yes, 2 is there. That means after 2, after the first 2 till the current point, it constitutes to 0. We can see 1 plus 4 minus 5 is equal to 0. So we can remove this node. So one by one, we will iterate back until we get the prefix sum 0 and remove from the hash map as well. So first we will remove 7 from the hash map. We remove 3 from the hash map. And we will remove these nodes from the linked list. Now we are left with 2 and minus 1. So again, so we already have 2. So till here we reached till here after removing these nodes. Now 2 already we have. Now 2 minus 1 is 1. So 1 is there in the hash map. No, it is not there. So we will add 1. So at the end, since we are not able to remove any of the nodes, so at the end, we will get the linked list such that there is no such sequence whose sums is equal to 0 if we see. So this is how we can solve this question. Now let's look at the solution. So we will create a vector nodes which will store the address of the nodes while moving front, and we will keep a pointer which will indicate to current node, and a sum map we will store the prefix sum. Initially, I have told that since we are not adding any value, so we have a zero value. This is cumulative sum that will calculate the prefix sum. So we will operate this while we are not reaching the end of the linked list. And first we will see whether we have found this target value. Target value means whatever prefix sum we got at this point, we will see whether we have got this earlier or not. If if the value is not equal to zero, that means we have earlier got also. So if we have got it earlier also, that means what we will do, we will iterate the linked list back and remove all the nodes from the vector also. We will remove those nodes. That means we are deleting the nodes. So we are popping the address from the vector. That means we are deleting those nodes, and we are decreasing the length of the linked list also. And we will, if we are moving back, we will again subtract those values to get the current cumulative sums. So in this way, we will remove all the nodes whose values constitutes to zero. If we haven't found that target value earlier, that means we will push that current node as well as that prefix sum in the map, and we will increase the length. So at the end, once we are done this process, that means we are left with only those sequences of nodes whose sum is not equal to zero. So we will see if the length is equal to zero, that means we are not left with any of the nodes. So in that case, we will return null. Else, we will keep the first nodes of this nodes in this vector will be the head, and from the second node we will add in the next pointer of the linked list, and we can. I hope the problem statement and the solution is clear. If you have any questions, mention in the comments below. See you in the next video. Thank you.